Here's a quick video where I show the use of a rotary encoder in combination with an AVR microcontroller. This is actually a follow-up to a video I posted on YouTube several years ago and never posted the source code for. I get emails about that video all the time, so I figured I'd just go ahead and recreate the basic functionality and this time do a better job documenting the code. But the purpose of this circuit is to listen to a rotary shaft encoder, which can spin infinitely in any direction, and in this case it's adjusting the brightness of an LED, and it's doing this digitally using pulse width modulation. So I have an oscilloscope probe going to the LED, and we can see what the signal looks like as I spin the rotary encoder in two different directions. So the larger the duty cycle is, the brighter the LED gets, and that's pretty obvious. The rotary shaft encoder interfaces the microcontroller using 3 pins. Now if I were just listening to left and right, then it would only need 2 pins, but this one has a button press, so it's a rotary encoder switch, and my applications make it convenient to have right and left turn as well as push and turn to do different things. And I forgot to mention a minute ago that this is what the rotary shaft encoder looks like. You can get these in bags of like 50 or 100 pretty inexpensively, and you can get an assortment of caps. Some of them fit, some of them don't fit. You got to be careful. The one that I'm using here actually doesn't natively fit this post, so I had to use a little bit of super glue to get it on there. But once it's on there, it does pretty well. It has 3 pins. Here, the center one I used for ground, and the other 2 are for R1 and R2. And on the other side, it has 2 pins which are for the button, and I ground one and use the other one to be pulled high. And then it has 2 mounting pins if you're going to solder it to a PCB or something. So that's what it looks like on the inside. So just a real quick summary, the purpose of this video is not to talk about how rotary shaft encoders work, or even how to analyze them in software. You could use a hardware-based interrupt system, or you could use a polling method. In my sample code I use a polling method, but it pretty much watches the R1 and R2 signals, which get pulled low in a different order based on whether it's a left turn or a right turn, and finally a button press. And it's worth noting that I use the external resistors to pull all of these high, and then the switch, when it's activated, pulls them low very quickly, and the recharging is slowed down by a debounce capacitor, which hopefully reduces some of the noise and likelihood that you get a false signal. And my demonstration code that I'm going to post has 2 functions in it. One of them is the simple one. It's the poll encoder version 1, and it just listens to left and right turns, and that's the one that we looked at earlier. This longer one is also smart enough to detect button presses, so like push and turn. So I'm going to change V1 to V2, save it, and then program this microcontroller. And the code's being loaded over the programmed the chip. So now we have the same functionality as before, where I can adjust the brightness by turning in either direction, or I can push and twist and turn it a lot faster. So that's the push and twist versus just the twist. So again, I'm going to do a better job. Unlike last time, I'm going to post all of this source code on the GitHub, and if anyone has any questions now, they're welcome to send me an email.